These are the chapter review exercises for Module 6. Okay, this vertical line here is a perpendicular bisector. We can see that it's a bisector and it's perpendicular. And a point on the perpendicular bisector is equidistant from the endpoints of the base that is perpendicular to. So x plus 6 is the same distance as 22, and we can set the algebra up and solve that. So x plus 6 equals 22. Take away 6, x is equal to 16. Looking at number 2, same idea. We've got perpendicular. It's a bisector. So 2x plus 11 length is equal to 4x minus 5. Take away 11 from both sides. Take away 4x from both sides. Minus 2x's is equal to minus 16. Divide by negative 2. X is equal to 8. Let's move up. For number 3, we have an angle bisector. An angle bisector is equidistant, measured along the same angle, from a point on it to the side of the angle. So we can see this is an angle bisector, and what an angle bisector does is give us two congruent angles. So these two can be set congruent to each other. Two equals 4x plus 5. Add 2 to both sides, take away 4x from both sides. X is going to be 7. Same thing here. Equidistant from, well, perpendicular to the sides. And on this ray must be an angle bisector. So 4x plus 3 is equal to 8x minus 9. Take away 4x from both sides, add 9 to both sides. You get 4x's is equal to 12, which leaves x equal to 3. If we check it, 12 and 3 is 15, and 24 take away 9 is also 15. Let's move up. Okay, this deals with triangle inequalities. We want to list side lengths in order from greatest to least, from least to greatest, and the sides of triangles are in ratios compared to the size of their opposite sides. So if we have a 17 and an 81, we need to find out what the measure of angle A is first to be able to get these in order. So right now we've got 17 is the smallest, 81 is the largest. We need to find out what this angle is here in between. 17 and 81 adds up to 99. 99 subtracted from 180 is going to be 81 degrees. Let's check that. 162, 172, 179. So that's not right. This is going to be 82 degrees. 82 and 81 is 163, 173, 180 degrees. So this is an 82 degree angle. So we actually have 17, 81, 82 in terms of the order of the angles. So the sides opposite those are in the same ratio. So least to greatest, the side opposite the 17, which is AC, is smaller than the side opposite the 81 degree angle, which is AB, which is smaller than the remaining angle, which is opposite the 82, which is CB. Okay, let's look at number 6. Let me change colors over. So look at number 6. Here we have a 32. Here we have a 90. That's 122 degrees. Another 58 degrees gives us angle K. So in order, we have L smaller than K, smaller than J. So sides are going to be the same way. Opposite L, KJ. Notice that the side, if you use the one letter way of naming the angle, the side includes the other two vertices of the triangle that aren't used by that angle. So We've got K. K, it goes with LJ. Let's look K, LJ. And J is going to be KL. So that's the order of those. Let's look at number 7. Here they're giving us all the angle measures. So right away, if we go smallest to largest, the 37 is the smallest. Opposite that is YX. The middle size angle is the 45. Opposite that is YZ. And then the largest angle is this 98. And opposite the 98, we have ZX. So those are those 3 in order from smallest to largest. You could actually do inequalities also. Really, technically, inequalities aren't really correct, because if you're dealing with distances, maybe it should just be like YX less than, because YZ less than ZX, because that way you're dealing with numbers and comparing the numbers. But it's okay for right now. Let's see unknown angles in order from least to greatest. So this is the converse idea. We're going to use the side lengths, and then the angles opposite those side lengths are going to be in the same order, size-wise. So we start with an 8, then we have a 10, and then we have a 14. So we put the inequalities in. So now the angle that's opposite the 8 is angle E. So E is the smallest angle. So we say the measure of angle E is less than, now we're talking about the 10. 10 opposite that is going to be D. Measure angle D. And that's going to be less than. And then now we're looking at the 14. 14 is opposite angle F. So we got angle, measure of angle E is less than the measure of angle D is less than the measure of angle F. So E less than D less than F. Same thing for number 9. Biggest side, 26, opposite A. Measure angle A less than. And 24 is the next one. Opposite that is C. Measure angle C less than. And then the smallest side is 22. Opposite that is B. Measure angle B. So we have A less than C less than B. So look at number 10. We got 17 and 18 and 25. So in order, 17, 18, 25. Opposite angles, 17, angle R. 18, opposite angle S. 25, opposite angle T. That's how we would get those in order. Sometimes it's tricky picking the angle out, depending on how the triangle sits. Sometimes it helps to turn your paper around to the other side to get a better view. Talking about whether triangles can exist or not with given side lengths, the sum of any 2 has to be greater than the third. So if I look at combinations here, 1 and 6 is a 7, 4 works. 4 and 6 is a 10, 1 works. And 1 and 6 is 1 and 4 is a 5, but 6 doesn't work. So let's see that. 1 plus 4 is 5, but we have a 6. The sum of any 2 has to be greater than the third. So that one's not going to make a triangle. Let's look at number 12. 17 and 17 is 33. There's 34. That's bigger than 33. 17 and 33 is 50. That's bigger than 17. And then the other 17 also works. So that one's going to work. Looking at 13, we have 22 and 26 adds up to 48. 48 is not bigger than 65. That's not going to work. As soon as you find one that doesn't work, the whole thing's not going to work. Let's look at this one. 6 and 43 is equal to 49. So it's not going to work. It has to be greater than 49. 7 and 54, bigger than 45. 7 and 45 is 52. That's not bigger than 54. It's not going to work. And looking at this one, we automatically know this is a 3, 4, 5 Pythagorean triple. It's going to be a right triangle. Good combination to know. 3 and 4 is 7. Takes the 5. 4 and 5 is 9. That takes care of the 3. So we know it's going to work. Plus, automatically know because it's a 3, 4, 5. Another good one to know is 5, 11, or 5, 12, 13. 25 and 144, 169. That's the Pythagorean theorem. That's another Pythagorean triple that's good to know. BTW. Find the range of lengths of the third side. So we can do inequalities with these. If we're given two sides, the third side has to be in between the sum and the difference of these. So 12 and 6 is 18. 12 take away 6 is 6. The third side, let's just call it S, has to be bigger than 6 and less than 18 units. So we're doing plus, minus. Same thing here, plus, minus. Plus gives us 11, minus gives us 5. The third side has to be bigger than 5 and less than 11. So we can write it as one inequality. We could write it as 5 is less than, see how the 5s kind of look the same for me. I'd do that with the S's. And S is less than 11. So you could write it as two separate inequalities or one compound inequality. Okay, let's move on. Okay, so for these two, determine which third length is longer. This is called the Hinge Theorem. And what goes on with this is, notice that we've got two sides that are congruent. We've got another two sides that are congruent. But the matching angle, or the angle in between, so this is like an S, sort of an A, S pattern. The angle in between, in this one, is exactly the same. So that means by SAS, these two triangles are congruent. So these are going to be equal. And LM is going to be the longer side. LM is going to be congruent to FG because these two triangles are congruent by side angle side, and FG and LM are corresponding parts of congruent triangles. Let's look at number 20. Let's switch colors up here if we can. Lost my nib here. Hold on. Okay, here you've got this side congruent to this side. That's an S pattern. You've got this side congruent to this side here. That's another S. And we got the angle in between. Now this time the angles aren't the same size. The side opposite the biggest in between angle, or hinge angle, is going to be bigger than the side opposite the other angle. So DE is going to be larger than AB. And when you have this side angle side pattern, the two angles in between determine whether they're going to be equal, like in this one, or which side is going to be larger. The larger side is always going to be opposite the larger angle. So opposite the 110, we got DE. And same thing for 21. Let's look and see what's going on here. Okay, here we have the angle given to us. And let's look at the triangles. These two sides are congruent. It gives us an S. Here we have the angles in between. And then this side and this side are congruent. That gives us the other S. So that means we can just compare these two angles and see which side is bigger. The side opposite the 98, LS, is going to be the biggest side. So LS distance is going to be greater than MS distance. And that's it for those.